It's approaching -6 from both directions, and the numbers aren't constant. So -1. There's a removable discontinuity here, and the function intersects the vertical line at 2. -4. The limit at x approaches -4 does not exist because there is two. It's not a two-sided limit. And there's a jump discontinuity. So the limit does not exist. There's a removable discontinuity here. There's as the function approaches -7, the limit is 1.3. And as the function approaches -4, the limit is -5.2. There's a asymptote here and two infinite discontinuities. So the limit does not exist because both of the functions are not defined. I mean, they don't exist. The limit doesn't exist. They're unbounded on both. On the plus side and the minus side. So it doesn't exist. There's a removable discontinuity at 0.2, and as the function approaches -5, the limit is 1.7. -3. So as the function approaches -3 from the negative direction, the limit is -6. As the limit approaches 1 from the positive direction, the limit is -5. As the limit approaches -3 from the negative direction, the limit is 6. As a function approaches -1 from the negative direction, since there is a vertical asymptote and the line never truly approaches the point, it just keeps getting closer and closer, but it will never truly. It's an infinite discontinuity, so it's unbounded. As a function, so which of these graphs display that as the function approaches 1 from the positive direction, the limit is 0? Not this one. This one. This one. Okay. Which summit expressions agree with the graph? Limit x to the -4 is unbounded. That is true because there is a vertical asymptote here. Limit -4, no, it would be unbounded. -4 from both sides would be unbounded. X approaches 4 from the negative direction would be unbounded. So, oh, it would be 3. That's right. Which of these graphs show that as when the function approaches 3 from, this approaches 3, the limit is 5? This one, and pretty much all of them. Which summit expressions agree with the graph? As x approaches -3, the limit is 3. The limit would not exist there. As x approaches 3 from the positive direction, the limit is 1. It's true. As x approaches 3 from the negative direction, it's unbound. It doesn't exist. That's false. It would be -3. Just because it's not defined there doesn't mean the limit doesn't exist. Creating tables for approximating limits. So the table is always appropriate if the x values aren't constant and the limit is being approached from both directions. So they aren't constant and the limit is being approached from both directions. So the table is appropriate. Given the function g and asked to estimate limit x of x approaches 4, 3 students created tables. Each table is accurate, but which one is the best at for approximating the limit? So this one, there's a huge jump in x values, so it doesn't truly approach 4 from both directions. This one only approaches it from one direction, so that's false. And this one has to be the answer. This one is not appropriate because the x values are constant. This one only approaches -8 from one direction. This one's constant, so this one has to be the answer. As x approaches -2, the limit does not exist because there's too much of a jump in the function from 5 to 7. So the limit does not exist. At 0, it may be the function may be defined as undefined, but that's not the limit. You have to take the estimate from the surrounding values of x. So 2.9 is the best estimate for the limit as x approaches 0 for the function. The best estimate would be in between these two values of the function. So it would be -3. The most reasonable estimate would be that the limit doesn't exist because there's too much of a jump in the surrounding values for 4. for 1, approaching from the negative direction. So this is the negative direction. The best estimate would be this rounded. So it would be 2. The best estimate for this would be this flattened. Should be, wait, no. This flattened should be 1. This limit is approaching x. This limit is approaching -2 from the negative direction. Since this is constant, it can't be, you can't provide an estimate, so it's unbound. It's defined. As the limit as x approaches 7 from the positive direction would be this rounded. I mean, it would be -3 because what is a reasonable estimate for the limit of the function as x approaches -3? There's a removable discontinuity, which means that the function is defined here, but the limit doesn't exist there. So the limit would be at this hole, -5.3. What is a reasonable estimate for the limit of the function as x approaches 6? Be 4.17, because that's the closest value. Because the trend is it's losing 0.01 every increment. So it would make sense that it would go from 4.18 to 4.17, and from 4.18 on the positive side to 4.17 as it approaches 6. What is a reasonable estimate for when the limit of the function approaches -4 from the positive direction? Seems to be approaching -6. Constant. So the table is appropriate. Which graphs agree with the statement? The limit of the function as x approaches 0 from the negative direction equals 4. What is a reasonable estimate for the limit of the function as x approaches -1? -3. So in order to find the limit, the two-sided limit has to be satisfactory. So in order to find if the two-sided limit is satisfactory, what you have to do is multiply the negative direction. We'll just add the negative directions and add the positive directions together and see if they're equal. So 5 and 5. So it would be 5 plus 5. the limit wouldn't exist for this one. Because there's a jump discontinuity. Oh, I was wrong. Wait, no, it'd just be 5. It wouldn't be 5 plus 5. Same thing for this one, except it's subtracting. Be 1, and it would be 1. Because the negative side, 2, negative side of the h function, 1. The negative side, the positive side of the f function, 1. Minus the positive side of the h function, 0. Just get 1. The answer is 1. Since there's no jump discontinuity and it only exists at 1 point, the limit only exists at 1 point for h. You'd just be directly finding the definition from both points. Where it exists at both points, and you add them together. So b3 plus 2, 5. For this one, the limit doesn't exist because there's a jump discontinuity, and the only time when a jump discontinuity would exist is when one of the points was 0. So the limit doesn't exist. Wait, I actually take what I said last time back. The limit just didn't exist because there's a jump discontinuity. Anyway, since there's no jump discontinuity, you just find what the limit is at as x approaches 0, and that seems to be 3. Just do negative 2 times 3, and you get negative 6. This one, there's a jump discontinuity. However, the result would be the same no matter what, because one of the limit as x approaches negative 3 from the f function is 0. So no matter what, if you did 1 times 0 or negative 1 times 0, you still get 0. So the answer is 0. Zero. Zero. Oh. Oh, you can't divide when finding a limit, you can't divide a non-zero number by 0, or else the limit doesn't exist. So the limit does not exist when you have x over 0. So this time it's 0 divided by something. So limit would exist, but the result would be 0. 5 and 1, 5. 1 and 0. No, it does not exist. The answer would not be the same, so limit does not exist. The limit as x approaches 3, we start with PEMDAS, the function inside of parentheses. We define that first, and then we move that we define that value for the rapid function. So it's 2. So it would be Q2. And you just find 2 here. A vertical asymptote, it's unbounded both sides. Limit does not exist. Asymptote, limit does not exist. 0, -1, because it would be f, no, f, oh, f of 0, and that would be -1. So now we need to find limits by direct substitution. So all you do is just substitute in for, wait, no, it's not 1. It'll just be minus 15 over 3. You get -5. To substitute, get 9 plus 3 minus 1, you get 12. And then you get 11. You get 5 because you did 12 plus 13. You get square root of 25. Square root of 25 is 5. Three minus 25. Oh, 11. That would be -22 over 11. -2. Direct substitution with limits that don't exist. So this before 0, one does not exist. -4 squared, 16. 8 plus 5, 16 over 13. Minus 2 squared, 4. 0 squared, 0. It does not exist because you're dividing a non-zero number by 0. 7 over 20. Looking at a unit circle, pi is identified as 180. So 180 divided by 2 is 90. And 90 degrees of a unit circle is just a straight line up. So, and the unit of circle's radius is 1. So this point would be, it would be 0, 1. And then sine is the y value of the point, and cosine is the x value of the point. So the answer would be 1. The identification for CSC is 1 over sine. So 180 divided by 4 is 45. And the definition for sine 45 is square root of 2 over 2. So it would be 1 over square root of 2 over 2. Then you translate this up to the numerator. And you get 2 over 2. And then you'd multiply the top and the bottom by that. And you'd end up getting square root of 2 over 2. I guess not. So the definition of 180 divided by 6 is 30. And the definition of cotangent, the identification for cotangent is cosine over sine. And on the unit circle, cosine, the point for 30 degrees is, this is how you find it. So you start with 0, 1, then this becomes 3 over 2 and 1 over 2. Then it's square root of 2 over 2 and square root of 2 over 2. And then it's square root of 3 over 2 and 1 over 2. So cosine would be square root of 3 over 2. And sine would be 1 over 2. So it would end up being 3, square root of 3 over 2. It would just be square root of 3. Cotangent for 180 degrees. Cotangent for 180 degrees, the point 180 degrees on the unit circle is straight to the left. So, and the length of the line is 1. So the point is 1, 0. This is cosine. This is sine. And it would be 1 over 0. The limit does not exist. 1, as we just talked about. Negative 1. Section of 1. Negative 1, 0. sine over cosine is the identification for tan. On the unit circle, 90 degrees is a straight line upwards. The x value is 0, the y value is 1. Sine is the y value, cosine is the x value. It would be 1 over 0, and that does not exist. As we just talked about, the definition for sine on a 90-degree line is 1. The identification for cosecant is 1 over sine. The identification for 180 degrees divided by, for 45 degrees is, for both sides, for both cosine and sine, is square root of 2 over 2. So it would be 2 over square root of 2, 1 over. Wait, no, it would be, yeah, it would end up being that. Let me explain why first. And I just multiply the bottom, top and bottom. This is a mistake I made last time. Then it would be 2 square root 2 over 2. Cross out the 2's. You get this. The cotangent is cosine over sine. The limit, the unit circle, the point for 0, also 0 is also equal to 360 degrees. But the point for 0 is a line straight to the right. The unit circle's radius is 1, so the length of the line will be 1. Point on the far right side would be 1, 0. So it would be 1 over 0. The limit does not exist. Limits of piecewise functions. Alright, so since we're approaching 3 from the negative side, we're going to start from the side where x is less than or equal to 3. So that would end up being 9 minus 1, which is 8. And then after that, we do the same thing for this side. We're getting 7. It'll just be 8. Approaching negative 4 from the positive side to negative 4 is 1 over 2 to the 4th power, and that would be 1 over 16. Approaching negative 3, both sides matter. They have to be equivalent to each other when you substitute, and you'd end up getting 2 and get 4. Wait, no. Yeah, you get 4. So both of these have to be equal to each other. Negative 5 and 1 over negative 4. The limit does not exist. So it would be negative 5, and it would be, yeah, it would be 1 over negative 4. Guess I should have checked the constraints first. Negative 3, it's not. So this constraint doesn't matter. This constraint's the constraint that actually matters. this constraint doesn't exist in the problem. So just supposed to be -5. As E is being approached from, -1 is being approached from the negative side. This would be the constraint we use. This constraint also needs to be proven as well to be equal to the first constraint. So it would end up being E, it would just be 1 over E. And so it would be 1 over E and and the other constraint would also be -1 over E. So it does not exist. Okay. It's 1. Because we'd be using this constraint. This constraint also, so it would be 0. So it doesn't have that. Approaches 3 from the negative side. This would be one we use, and this would not be one we use. So this is as it approaches it from the positive side. So it would be negative. I mean, it would be +5. I mean, it would be +8. For this one, it would be 2 times 2 times 2 times both of these. This one's approaching it from the greater than side. This one's approaching it from the negative side. Both of these have to be equal to each other. So it would be 4, 8, and it would be 16 at the top. 8 square root 4 is equal to 16, so these two are equal to each other. 16. 16 minus 1 at the top, and 2. So as x is greater than or equal to 1, so this side would be the approaching 4 from the positive direction. And this side would be approaching +4 from the negative direction. These two are not equal to each other. It's funny. So the bottom would be equal to, well, it doesn't matter if it goes past 4, because this one is greater than or equal to 1. Yeah, so it doesn't matter if it moves past 4. Limit is still the limit. Now on this side, this one doesn't, this one stops at 1, so this one wouldn't. Yeah. ln, this one, it approaches it from the negative direction, This one approaches it from the positive direction. So these two have to be equal to each other, or else the element does not exist. So ln2, and it would be 4 ln2. These two are not equal to each other, the element does not exist. This one is the greater than direction, and the answer would be 1. Wait, no, the answer would be 0. X approaches -1. This one approaches it from the negative direction. This one approaches it from the positive direction. These two have to be equal to each other. 0, -1. Wait, no. It would be -1 over -1. It would be 1. Wait, no. It would be -1. So both of these are equal to -1. So it would be -1. X is greater than, X is less than -2. So this one approaches -3 from the negative direction. But it never fully approaches -3, so this one doesn't count. This one approaches -3 from truly, this one approaches -3 from the positive direction, but it never truly reaches -3, so. Oh, but that would be, it's never supposed to truly approach -3 because it's the limit and it has to be an estimate. So let's just get to substituting. -5, 1 over, I've already done this one before. And this one approaches it, does approach it from, this one does approach it from the positive direction. This one does approach it from the negative direction. Less than or equal to, greater than or equal to, greater than or equal to. That's the problem. Greater than or, it's greater than or equal to x. X is greater than or equal to -2. So it never approaches -3 because it always has to be greater than or equal to -2. The constraint is that the furthest it will go is -2. So -5. All right, so this approaches -3 from the negative direction. This approaches -3 from the positive direction. These two have to be equal to each other because there's no defined direction it's coming from. It would be -4, and it would be 2. Wait, no, it would be 4, and it would be 2. It does not exist. -4 from the positive direction. This is the one that approaches -4 from the positive direction. This one approaches -4 from the negative direction. This is the one, the constraint of concern. 1 over 16 is the answer. This approaches pi from the negative direction. This one approaches pi from the positive direction. These two have to be equal to each other. 0.
Replace your sheets.
Well, so these are probably.
You're not gonna have time to do this, son. You're not gonna have time to do this. We need to put it back in. Wash his